Hello everyone, I welcome you in physics classes. Dear students, in my last lectures I taught you about the AC passing through resistor, inductor, capacitors and power in AC circuit. Okay, so today our topic is again a very important topic, that is transformer. And many questions of MCQ types or 1 mark questions or 2 marks questions are coming from this topic, that is transformer. So let us see the subtopics, that what are the subtopics which we will discuss today. So in transformer we'll study about definition, we'll study about the principle of transformer, construction and working with its types, mathematical treatment means its theory we will discuss here, energy losses in transformer, and laminated core means why does the core of transformer is laminated. So students, one by one we will take all these points. So let us start from very beginning, that is definition. So dear students, transformer is a device. Transformer is what? It is a device which is used for converting high voltage into low voltage and vice versa. Means if you want to convert high voltage into low voltage or low voltage into high voltage, then one device we are using, that is called as transformer. So what is the principle of transformer? Principle of transformer is mutual induction. It works on the principle of mutual induction. Many times this question is asked in MCQ types, that which of the following is principle of transformer. So students, keep in mind that principle of transformer is mutual induction. Now what is mutual induction? Pause the video for a while and think that what is this mutual induction? We have studied already. Yes, mutual induction is the phenomena of production of induced EMF. Okay, but why and where? So it is the production of induced EMF in the neighboring coil if the magnetic flux or the current changing into the another coil. Okay, so students, you have studied already this mutual induction, like this is the phenomena due to which induced EMF is produced in the neighboring coil whenever any current or magnetic flux changes in the single coil. And always we are taking the two coils, primary coil and secondary coil. So students, here also we are taking two coils. So let us see the diagram. In your diagram, you can see that this is the core, means the central point of the transformer, and it is made up of soft iron. We make it of soft iron. Now question arises that why core of transformer is made up of soft iron? So it is made up of soft iron because the soft iron hysteresis loop we have drawn and its area is very less. That's why energy loss per cycle is also very less. Okay, its permeability is less, you can say. So students, that's why the core is made up of soft iron and we are laminating it. Now what is the meaning of laminated? When you are laminating your mark sheets, then what you are doing? You are just putting one more layer on your paper. Okay, for example, if I have my Aadhaar card and I want to laminate it, what I will do? One more layer I want to put on it so that it will be safe. Okay, so same we are doing here. We are laminating our core, means soft iron core we are putting 2, 3, 4 or more strips together. Okay, one strip over the one, second strip, third strip, fourth strip. Here I have taken only 3 strips, but you can draw more strips also, and that we call lamination. Why it is laminated? So that we will study at last. Okay, so students, you can see here that I have binded it from both sides. On the left side I have written EP, means here the primary coil is there, and on the right hand side this is called as secondary coil. P coil and S coil, primary coil and secondary coil. Through primary coil you will give input जिसको हमें convert करना है, and on the secondary side, secondary coil, we will get output, means the converted one. If you are converting high voltage into low voltage, so high voltage we will give across primary coil and low voltage we will get across secondary coil. I hope you understand the meaning of input and output. As in your computer period also, you are feeding input and you are getting output. So same is the concept here also. Okay, so let us proceed towards this construction and working. Students, construction, already I told you that it has two coils, primary coil and secondary coil. Okay, next is types, that how many types of transformer is there. So students, the types of transformer is two, that is step up transformer and step down transformer. Now what is step up transformer? Step up, as its name is suggesting, low voltage to high voltage. हम लो वोल्टेज को किस में कन्वर्ट कर रहे हैं? हाई वोल्टेज में. सो इफ लो वोल्टेज यू वांट टू कन्वर्ट हाई वोल्टेज, मींस नंबर ऑफ टर्न्स इन प्राइमरी विल बी लो. वोल्टेज लो है तो नंबर ऑफ टर्न्स शुड बी लो, एंड high means number of secondary turns would be more. Number of primary turns will be less, number of secondary turns will be more. This also comes in MCQs, that in step up transformer which number of turns are more and which number of turns are less. So here you have to use common sense. क्योंकि step up हम low से high में convert कर रहे हैं, तो मतलब primary number of turns low होंगी और secondary number of turns high होंगी. That's why I have written NP is less than NS. And similarly in step down transformer, NS is greater, NS is less than NP. Okay, that means the number of secondary are less, number of primary are more. Now let us say it's mathematical treatment. Mathematical treatment means mathematically how can we write it. Okay, so students, let us suppose coils are both sides, so phi P. Phi means magnetic flux. So let us suppose that phi P is the magnetic flux in primary coil and phi S is the magnetic flux in secondary coil. Okay, so magnetic flux with P and S coil. So students, obviously more is the number of turn, more will be the magnetic flux. So phi P upon phi S is equal to NP upon NS. From here you can write that phi P is equal to phi S will go up. So NP upon NS into phi S. And students, this is very, very important formula for numericals. Okay, for numericals, sometimes they are giving you magnetic flux of primary coil, magnetic flux of secondary coil, number of turns of primary coil, and they'll ask you calculate number of turns in secondary coil. Or they can ask anything else also. It depends upon numerical. Okay, so now what is next step? Differentiating both sides. So differentiation हो गई d phi p upon dt, np upon ns, ddt of phi s. So d phi upon dt according to Faraday's law, it is equal to EP and this is equal to ES. So this is again very important numerical formula. So you can see both I have enclosed in box and I have written here that important for numericals means you have to keep it in mind. Our next topic, or you can say that tomorrow, means whenever we will meet together, then we will solve these numericals based upon these two formulas. Okay, so let us start. Next one, that is where we reached here, energy losses in transformer. Now question is that where does the energy may loss in transformer? Okay, obviously nobody is perfect, everywhere there are some losses, but question is that what is the reason behind these losses? So let us start discussing it one by one. First loss is flux losses. Now flux, obviously we are talking about magnetic flux. We are talking about this loss, that is flux loss. So what is flux loss? Students, as we are coupling, we are connecting primary coil and secondary coil with each other. Okay, but you know, as I told you that nobody is perfect. That means coupling or connecting primary and secondary coil is also never perfect. Whatever magnetic flux we are linking with primary coil will not produce whole of it whole of its magnetic flux will not get linked with the secondary coil. That means EMF will not be full. Okay, there will be some loss due to magnetic flux. Okay, that is called as flux losses. Simply you have tried that flux losses means that the coupling of primary and secondary coil is never perfect. Some of the magnetic flux get lost due to coupling reason. Okay, I will give you notes also for PDF. In the form of PDF, I will give you notes. Okay, next is copper losses. Now students, as you know that we are binding our primary, soft iron core, we are binding with coils. Okay, and that binding we are doing with copper. And copper, obviously it's a metal, so it has a resistance, and if it has a resistance, so some heat will be produced. Means electrical energy will be wasted in the form of heat. So that we call copper losses because it was in copper. Okay, third one is, your third loss is iron loss. Now what is iron loss? Iron means your soft iron, and whenever iron is there, obviously the eddy currents will produce. Eddy currents means the currents due to change in magnetic flux. We have given these names, eddy currents, and eddy currents are produced which are not good for our transformer, and electrical energy gets wasted in the form of eddy currents. So this is the third loss, that is iron loss. Fourth one is humming loss. Humming, what do you mean by humming? Yes, humming means just like your honeybees are producing sound. That is called as humming sound. Okay, so if you have observed, then iron is also producing humming sounds. If iron you want to take from one place to another place, or if current is flowing through iron, obviously it will start vibrating and it will produce some humming sound. Okay, just like honeybees, it will produce sound. That means electrical energy is wasted in the form of sound energy. Okay, so students, these are 4 losses in transformer, and very important from examination point of view. Okay, next is efficiency of transformer. Efficiency means कितनी इसकी क्षमता है काम करने की. Okay, so it is always measured output divided by input. We have calculated efficiency so many times. Efficiency means कितना आपने काम किया, कितना आपको input मिला था. Okay, कितना आपने खाना खाया और कितना आपने काम किया, उनकी रेशो को क्या बोलते हैं हम? एफिशिएंसी. ओके, सो हियर इट इज आउटपुट अपॉन इनपुट, आउटपुट पावर अपॉन इनपुट पावर. Power I told you in power in AC circuit also we did. It is the product of voltage and current. So secondary output means secondary turns. So ESIS upon EPIP. So this is the efficiency of transformer. Okay. So now let us come on the last topic, and again very important, for 3 marks they are asking it. Why does the core of transformer is laminated? Now students, in your examination masters or any short or any other helping help books, you will get this answer only in one line, that to minimize eddy currents the core of transformer is laminated, but you need to write its explanation. Okay, so let us start. Why does the core of transformer is laminated? So first line you have to write, the core of transformer is laminated to reduce eddy currents, to minimize eddy currents. Okay, explanation, as we know that soft iron has very less resistance. Less resistance means current will flow more and more heat will be produced. If more heat is produced, then it can damage the insulation of your copper wire. जो copper wire आपने यहाँ पे लगाई हुई है, insulation of this wire may damage due to high current, due to high heat. Okay, so hence we laminate the core by preparing or joining similar iron strips together. As I told you, iron strips को एक साथ जोड़ा जाता है. Okay, so the eddy currents in each iron strip will be produced separately. हर एक iron strip में current और eddy currents होंगे, that will be separately, and as a whole it will get minimized. Okay, so this is all about my today's topic, that is transformer. I hope you understood it. For any query, you can send me message on my WhatsApp number, and for notes I'm going to share one PDF with you, so please prepare notes based on the same topic. This is enough for today. Thank you. Have a good day.